We start our lecture today. So it's November 2nd. So it's a week 9. Nice. Oh, thank you. Thank you. So it's week 9. The nice week 9. And next week we are going to have the exam, the first exam. So week 10th, and we'll include up to the GMM here. And today I will teach you not only the background subtraction. I try to finish this one, and then I will also teach you the AI on the posterior probability. Is this part? Okay, I already put a lecture on the FTP site. So the exam will up to the week 7. And for the homework, the same, I encourage you to discuss with each other. Okay, the homework. If you have any question, you can ask the TA, or you can discuss with each other for the homework. And usually for the homework is a little bit more than regular thing. And what I mean is you need to spend a lot of time doing the homework. Okay, but for the exam, it will be easy. Okay, so exam, most of the exam, the answer, the question will be like the physical meaning. So I ask you and then ask you what's the physical meaning for that one, and I give you the 4 selection. And you just pick up one. That's one example. Okay. The second example is for your homework, you will do the calibration, right? Camera calibration, and we have a step 1, step 2, step 3, and I will give you like suppose they are totally have 4 steps, and I give you probably six answers, and you pick up 4, and you sort the step. Okay, but I will give you. I say okay, there were 6 selections, and you pick up 4, and you sort it, and that will be your answer. So probably I think that the most of the answer just it's just a selection 1, 2, 3, 4, something like that. Okay. And so next week the exam for the time, it will be 1 hour. It's actually like 15 minutes for the first hour of this lecture, and then second hour and third hour will continue my lecture. Okay, for next week. So again, it's most of the physical meaning. Ask you the physical meaning, but the physical meaning I also give you the selection. So you just pick up 1 or 2 or sort the answer, something like that. So we continue this one, background subtraction. So the same. The purpose for the background subtraction is I try to teach you the Gaussian mixture model. This way, each lecture behind the lecture, I will teach you some technology, and I just use one example to explain to you. So this one is a mixture or Gaussian mixture model, or mixture of Gaussian model, and I use the background subtraction to teach you instead. So this already tell you. So we'll continue. So this is one example is this is a background. Background is meaning they don't have any object you want to have. You want to extract. And then suppose I want to extract the people or the vehicle or the bicycle, motorcycle, something like that. So after several seconds, we have a new object come in. And how can you extract those objects? We can use background subtraction. And the method for background subtraction, okay, the speed is very fast. Actually, I mean, usually it's faster than 30 frames per second. So it's a very easy and good method to do what we call the pre-processing to extract the object. Okay. So we do detection, we do tracking, we do recognition. And background subtraction is one kind of detection. So when you do the deep learning, for example, you use the faster RCNN and you detect the object. That's one method. There's the other method is background subtraction. You can use the deep learning to do the modeling of the background. Okay, and after you modeling the background and you put the object and it will extract, or we call segment the foreground object from the background. So it's extract it out. So the other method. Okay, and background subtraction compared with faster RCNN. Faster RCNN is you try to detect the object using the bounding box. So actually, you don't know exactly the shape, the boundary of the object. But background subtraction, you can extract the shape of the object. So one method, I teach you one method. The first, only one. I mean, not. I should say the most of method is using the Gaussian modeling. The Gaussian modeling. So back to our purpose, I try to teach you the Gaussian modeling. So I say if the signal, like this way, the signal, for example, is that there's a pixel here. There is a pixel here. And the pixel, because in this position, okay, the pixel will change the gray value because sometimes this pixel is one pixel of the leaf, 树叶. Sometimes the 树叶, because the leaf will move. So sometimes will be the sky, the background sky. So you will see one pixel here. The motion, the change is this is 900 frames. Okay, and this gray value for that pixel. So for the background subtraction, if your resolution suppose is 1K times 1K, for each pixel, you need to use one Gaussian model to model it. So if they have a 1K by 1K, it's 1,000 pixels. So you need to have a 1K by 1K Gaussian models. Okay, so for the background modeling, and we apply to the background subtraction, they will take a lot of memory. That's their weakness. Because each pixel you need to model it. But the background subtraction is very powerful and very easy method. Okay. So back to here is we see, so suppose we have a signal like this one. Okay. And this is a time, the frame, and this is a gray value change. And this one we call histogram. The histogram. In the other lecture, I think it's chapter, I forget, chapter 7, something. Chapter 7, that the entire chapter is talking about a histogram. So the histogram, this is x-axis, this is the y-axis. This 2D histogram. If they are 3D histogram, they have x, y, z, something like that. Okay, so suppose this is a histogram. Can you model the histogram? Can you? In my other lecture for the undergraduate, we talk more about the histogram. And back to here. Okay, so this is not easy to model. So if we change, because it's a change a lot. So if we move to the other, transfer to the other space, so become like the x-axis is gray value. The y become the frequency. It's gray value. Frequency actually is the what? Is accumulation, 就累加. So for example, in this one, okay, this gray value. So this y-axis is gray value. We moved, transfer to the x-axis is gray value. So suppose if the gray value is 100, and how many pixels has gray value 100? So we accumulated this one. And I just talked you about the SIFT. SIFT also use histogram become your descriptor. So histogram is very important. This one. And back to here. So this is the accumulation. 这是累加哈，就是说哪个灰阶值，这里的灰阶值，你哪个灰阶值，你去累加它的个数，就这个 histogram. Okay. And when you do the histogram, the second step you need to do is normalize the histogram. So normalization of the histogram has just two methods. One is the maximum one will become 1. Or we can call it the probability of 1. It's one method. The second method is that the entire area, the summation of entire area is 1. Like the Gaussian model. 这只有2个方式哦 ，histogram 要做 normalization， 你才把处理。So when after you build the histogram, you need to do the normalization. Use 2 methods. One is the pick is 1. The other is the entire region. The summation of entire region is 1. And that means the probability of the y-axis. 就 y 轴的几率这样子。Okay, so after that one, we start to do the modeling. Okay, so this one, see, this one doesn't look like a Gaussian. This one is more similar to the Gaussian, but still not a Gaussian, one Gaussian, no. So what we can do is that we can use, suppose, if we use the vector quantization to do the clustering. So we cluster to 3 clusters. And each cluster, we use one Gaussian model to model it. So that meaning the Gaussian mixture model can model any kind of the distribution. That's important. Okay. So that's also meaning what? Meaning when we do the linear combination, any linear combination can approximate any distribution. And the linear combination, usually we can use the Fourier transform. So why the Fourier transform is important? Why signal process is important? Because the Fourier series, I mean the basis function, we call basis function of Fourier series is cosine theta and sin theta， 就是说任何的讯号的分布都可以用线性组合来组合。那线性组合最重要就是傅立叶转换。那傅立叶的话，基本上不管在 spatial domain or frequency domain 都是 cosine 跟 sin 的组合。那 cosine theta is a Gaussian distribution. It's a low pass filter. Sin theta is a high pass filter. It's the shift or the phase shift 就象限90 degree of cosine theta. I say again, the sin theta is a shift of the phase by 90 degree， 就两个是90度的误差嘛。So cosine theta is a low pass filter. Sin theta is a high pass filter. And this kind of combination we also call wavelets. My example will ask you this kind of question. So when probably you don't know the wavelets, but wavelets is very important. Okay. And usually the signal processing will teach you wavelets. Wave is the wave format. Wave is meaning signal. It's meaning cosine theta, sin theta, signal. Lets, L-E-T. Lets is meaning small and many. 小波 small one and many. That's mean L-E-T. S, lets. L-E-T 加 S. So wavelets is meaning we have a many cosine theta and the sin theta. That's distribution. This Gaussian distribution. We do the combination of the Gaussian distribution based on its amplitude 大小 and its phase 那个standard deviation 宽度 do linear combination. Okay, so because any distribution can approximate by the Gaussian model. Again, sin theta is the cosine theta, but shifted 90 degree. So also it's kind of like a Gaussian, but Gaussian is low pass filter. Sin is a high pass filter. So that's meaning any distribution can be approximated by the Gaussian model. Okay. So that's in this example, we can use 3 Gaussian distribution to approximate 去逼近这个 distribution. 好，那我们就开始讲。So we talk about the Gaussian mixture model, the GMM. Okay. And the first one we want to teach you is the parametric model. Parametric model. So for any model has 2 kinds of modeling. You want to model the model. Okay. So with 2, one we call parametric, the other we call non-parametric. 就参数型跟非参数型。Okay. So the Gaussian model is easy because the parameters is only mean and standard deviation. So that's their parametrics. So we continue. So this is the Gaussian model. And we have the mean value mu. We have a standard deviation here. Okay, so if it's a 1D and there's only 1 mu and 1 standard deviation, so this is Gaussian. If you have a more than 1 Gaussian model, and then for suppose you have 3 Gaussian models, so you have 3 means, 3 standard deviations. Okay, so that's called Gaussian mixture model. So this distribution can be the combination of this equation. So K will be equal to 3. So you do the linear combination. Okay. But for each distribution, we need to give in the weights. So weights here. Because we want the entire area will be equal to 1. So that's meaning 3 Gaussian distribution, each one you need to assign a weighting to him. So what's the weighting here? So the weighting here is based on the vector quantization. This is one method, very powerful and very useful method for clustering, 分群. It's a unsupervised learning, VQ. So if you give them any kind of a distribution, 1D, 2D, 3D, they will automatically do the clustering. So in our example, if you give in this distribution, they say, oh, here they will exist 3 distribution. So K will be equal to 3. And then VQ will also tell you what's the ratio for each distribution. So for example, if the ratio, the area of the ratio, suppose this is a 5 by 2 by 3, 就它的占的那个面积比是假设是5比2比3 5 by 2 5 compare is 5 to 3 for the ratio. So your weights will be, the denominator will be summation. So 5 plus 2 plus 3 will be 10. So the denominator will be 10. So the first distribution will 5 of 10. The second will 2 of 10. The third will be 3 of 10. So that's your weights. And you sum of them will be your probability. This will be your probability. And next hour, I will teach you why this probability is important. And this probability we call likelihood probability. Likelihood. That's what I want to teach you is that here. This one. On the second page. For the AI, the most important one for the AI we call Bayes theory. 贝氏定理 Bayes theory. Okay, for the Bayes theory. And Bayes theory will proportional to 正比 to prior probability times likelihood. And I will ask you, what's the prior probability? What's the physical meaning of prior probability? And what is the physical meaning of likelihood probability? I'll teach you next hour. So if I give you this one, so the Gaussian model here, I will ask you, is a posterior probability or likelihood probability? Difference. And the answer is this one is a similarity measure. So it is a likelihood probability. I say again, the exam will ask you, first of all, what's the Bayes theory? So it's this one. And Bayes theory will include posterior equal to likelihood times prior and divided by 1 normalization term K. So the important one, even though some paper, they don't really understand this one. So I will ask you, which one is the likelihood? Which one is the posterior probability? In our case, in this case, because this one is a similarity measure, 相似度量测. So similarity measure is a likelihood probability. I will teach you later. 那我不晓得你们有没有去修人工智慧的课，我也不晓得老师怎么教你们。那我只是跟你讲哈 ，When you take the course about AI, and AI the most important one, I tell you is Bayes theory. It's that one, posterior probability. But the important concept is you should understand the difference between posterior probability and the likelihood probability. 这两个不一样哦。那学生完全很多都搞不清楚，老师有时候也搞不清楚。我教你，因为有些 paper 也搞不清楚，乱写啊，我要教你，这很重要。好 ，back to here. So that's meaning here we have 3 Gaussian models. So each Gaussian model we have many samples, and for each sample we just do the average, the value. So that's the average, the mean, and we based on the mean we calculate the standard deviation. So we have standard deviation for normalization, and this one covariance matrix is also covariance. Covariance equal to standard deviation square, right? Covariance equals standard deviation square. So this is covariance. This is also covariance. And I will ask you what's the physical meaning for this one, and physical meaning of this one. This Gaussian model. So that's one. Let's say for the Gaussian model. Later on, I will teach you this one about the Gaussian for next lecture. This AI, and in the here, I will teach you again the Gaussian model. I will explain to you. In the other lecture, I spend a lot of time explaining this one. Okay, so this is a Gaussian model, and I will ask you the physical meaning about this one. Back to here. So how can you do the non-parametric model to model your Gaussian model? You can use any model can do the modeling by parametric or non-parametric models. 任何的 model 都有2种 model。So I teach you what is a non-parametric model， 就非参数型。So here, the Gaussian has a mean and standard deviation. So what's the non-parametric model for the Gaussian? That's very important because usually the non-parametric model has better result than parametric model because this can be using for the learning. So first one, the Gaussian model is here. And previous one is we have 3 clusters. So we have 3 average, 3 mean value here. But for the non-parametric, meaning you don't need to calculate the mean value. You don't have it, and you don't need to calculate. So instead of the mean value, what we will do is that we collect the data. So for example, this one. So suppose n is the total number of frames. So suppose you collect 2 seconds of the image sequence. So that's a 60 frames, 60张影像，你收集60张影像。好，然后 for each pixel, this is 1 pixel. So we have for each position of the pixel, we collect 60 pixels. So you have a buffer. You collect the data. Again, I have suppose the image resolution is suppose 1K by 1K. So your buffer you should have each pixel you need to save. You have a buffer for the 60 pixels, but you have a 1K by 1K resolution. So 60 by 1K by 1K. That's your buffer you need to collect. And this is some basis concept for reinforcement learning, RLL. Why RLL is important? Why? Because it's unsupervised learning. Unsupervised learning is powerful. Compared with supervised learning, we have four kind of learning. One we call supervised learning. The other called unsupervised learning. The third one is a semi-supervised learning. The fourth one is a RL, is a reinforcement learning， 强制学习。这一般来讲，这是以前这种三种，一般我们讲三种。Usually we talk about only three types: supervised, unsupervised, semi-supervised. We don't talk about reinforcement learning, but right now the RL become very important because it's very powerful. Why? Why RL is powerful? Because when you play the game, the AI beat you. They use RL. They beat you. So it's important. Okay. Because RL can learn when the game using RL to model the parameters. Okay. And they play with you. First time, probably the AI lose the game, but he learn from you. But it's not only play with you. Probably in the internet, they play with 1 million people. So for each time they play one game, they have 1 million data collect. So they play with you. Actually play with the other 1 million people. So they have 1 million data. They play with you the second time. They lose you again, but they have 2 million data inside. So after they play 10 times with you, they become smarter. They can beat you later on. So that's it. So that's the RL. They're using the RL for the self-learning. Okay. So back to here. So they collect the data. The same here is we collect the data. We collect in the buffer. So what's the physical meaning of this term? The exponential term of Gaussian model. What's the physical meaning of this term? This term is meaning the difference. 相减. So what's the physical meaning of difference? Actually, it's a kind of variance. Variance, what's the physical meaning of variance? Variance 的物理意义是什么？就 difference. Variance 的物理意义就 difference. Difference 就是两个相减，就这样而已。So what they will do is here, instead of average value, average is meaning you summation this one, right? And then you do the average value become U. But we don't have a U. So what they do is x1 minus x2. And then this become 1. We have summation here. Summation here. 这应当有个 summation， 这里没写。And then x2 minus x3 and x3 minus x4, you sum all together, become this one. So that's a non-parametric model for the mean. 这样就结束了，两个相减，两相减，这样子。这个结果更好哦。This result is better than average value because it's the average will cause you the error. 你做平均值一定有误差嘛，你减实际的值就没有误差，所以你要收集实际的值，平均值有误差。你们全班平均 ，suppose the average value have some error, some we call bias， 有 bias，right？ 所以要减实际的值就没有了。So that's it for the mean value instead of mean value. Okay, and this is this is variance here, the variance here. So we keep going. So what's the standard deviation? How can you calculate standard deviation? So for the non-parametric model have a different kind of method. Even though the Gaussian model is different kind of method. So they in this paper talk about you can use the median filter. That's meaning the other way is here. The first one, the parametric we use the average value. The non-parametric have a method have two kind of method. One is just do the difference. The other thing is that instead of average value, we do the median filter, median value for this 60 pixels. We find the median value. So I will ask you, what's different for the physical meaning? What's different between the average value and median value? I give you 60 pixels. You find the average. And then I give you 60 pixels. You find the median. So which one will be better in reality? Median is better. Why? Because median filter is better than average filter. Why? In the other class, I'll teach them. I suppose this class everybody already learn image processing. 我会认为你们因为这堂课是研究所课，所以假设你们都学过影像处理了。那我那门大学不是教影像处理吗？那我就问你，那为什么 median filter 的结果比 average 还好？对 ，because average they will include is sensitive, is affected by noise. Median filter won't affected by noise. Noise is horrible. So the center here, if I use Gaussian model, right? The Gaussian model right now they have three kind of method for the average and for the exponential term here. So first method is the average value, and that's not good, but that's easy, but not good. The second is what? The difference between two pixels. That's cost the time. 花时间，对不对 ？If two weakness, one is the cost time, the second is the cost buffer， 占那个memory 嘛。The third method is use median filter, because median is better than average. But the weakness, the disadvantage of a median filter is because you need to do what? Sorting. So sorting, so that take time. So sorting is very important. Okay, so final one is how can you calculate the standard deviation? But we cannot use the equation. I mean the standard deviation equation, we cannot use that one. So one method they do is this one is a median result. Okay, and because they assume the Gaussian distribution, the one-time Gaussian distribution takes 68%. So they just give you the constant value for this one. 就是说这个标准的 standard deviation 这个答案很多种。那根据他的经验，他就给一个平均值除以这个值。那这个值是他的经验值，这很讨厌，很讨厌。经验值都是很讨厌的，就是他的 case 可以 work， 你的 case 不能 work。This constant value is based on the experience. We don't like this one. So they give in this median filter divided by this 68% times square 2. This means 2 standard deviation, something like that. So this paper, I give you this paper. The answer is this one, according to their experience. But this is not a good solution. So the one disadvantage of a non-parametric is sometimes they need your experience， 要经验值，那这很讨厌。OK， 好，那这样就结束了。That's it for the non-parametric model. So our answer will be this one. Giving you this, suppose we have background and we have one object is foreground, And after you do subtraction, you will become this one. Currently, our result is this one. But there still exists a lot of noise. There's noise. So can we get a better result of this one? That's what we need to do. So many of methods, even though you use the deep learning, we still need to have something we call the post-processing. The post-processing is very important. 就后处理。So deep learning, in this model, deep learning model, deep learning network, they have two processes. It's very important. One is pre-processing. The second is the post-processing. 所以你们在学深度学习要记得哈，深度学习为什么传统的方法很重要？因为这两个东西你跑不掉的，你没有这两个东西，你的 deep learning 还是做不好。那我都问你 ，if I ask you, in the deep learning, do they just put the original image into the deep learning, or they have some pre-processing? The answer is that they have some pre-processing. How do they do the pre-processing? Probably each image, they subtract with the average of the average value of that image and divided by standard deviation, become normalization of the input. 你不要以为 deep learning 没有做前处理哦，很多 deep learning 都没跟你讲，它有做影像前处理。它为什么 ？Why we need to do the pre-processing? Because two things: noise. The second is lighting. The light will affect your result. 你们像我们学生，我们学生有3组，一组人做 sports， 你就发现做 sports 人去那个中正堂，每颗摄影机弄出来色差，这颗摄影机比较鲜艳，另外一颗摄影机比较暗，比较不鲜艳的，有色差，有色温，那你就输入到你的 deep learning 出来结果，怎么跟我在实验室做的不一样？因为你没有做前处理，因为你没有处理光线问题，光线问题是很讨厌的。那电视公司，我们跟电视公司合作嘛，电视公司也跟你讲，你这个影像不好，很好，明明很好啊，看起来很好啊，说这个播到电视里面就不行了，因为你的皮肤颜色不对，所以皮肤颜色要变什么苹果什么颜色嘛，要化妆才行啊，一样啊，所以他跟你讲，你要调色温，我们学到这个经验了。所以电视公司不能随便播放啊，你要调到色温才有办法。那我问你，那 Real Sense 有没有色温？很便宜的1万块的 Real Sense， 你用 Real Sense 你有办法调色温？不知道，混学生才知道。所以这注意一下，这些都是前处理的东西哦。好，那 we talk about the post processing here. So suppose this image, how can we delete the noise here? This one probably already delete the noise, but after you do the background subtraction, you still have a noise. So how can we do this one? So their method is here. These two methods is useful. 这两个方法有用哦，你会遇到。The first method is here. Usually we use the one method we call non-maximal suppression, right? Deep learning has a non-maximal suppression, but that's just a concept for non-maximal suppression. 就是说你非最大值就把它杀掉，我只保留最大值嘛。The same as the maximal pooling, 对不对？然后你做那个 fast RCN use YOLO, the post processing is you have many windows are overlap, but you just pick up one. So this one, first of all, what they do is this way. this equation is meaning, suppose you have a window. In this example, they say, okay, the window size is 5 by 5. The purpose is I want to delete those noise. How can we delete the noise? Okay, the method they do is this one. First is suppose I consider either 3 by 3 or 5 by 5 windows neighborhood. Okay, because my purpose is background, B is the background, and N is the neighbor. So suppose neighbor is 3 by 3, but in their case it's 5 by 5. More neighbors. Okay, so if any this pixel, right? Any of my neighbor, they have a higher value, higher probability, higher value, this one, than me, and I will delete it. I will remove it. Because here, we want, this is the foreground. The white one is the foreground pixel. But there's noise. So any pixel, I compare with neighbor. So suppose the pixel is this one is the foreground. The background model is meaning what? Meaning if you belong to the background, your probability value will be high, because the Gaussian distribution based on the background information. So any value has a higher probability, it's meaning you belong to the background. If you low value is belong to the foreground. So those white pixels are the foreground. So any pixel, you will see this pixel actually look like an individual pixel. Not delete the pixel, do individual foreground. So how can we remove the individual foreground? It's meaning, okay, I compare with my neighbor. Any neighbor value is bigger than me. It's meaning I have a foreground. I have a background pixel. And then I will remove this foreground pixel. 我要讲一遍，它的原则，因为这个每个 pixel 都是独立的嘛，这是它的特色。它做出来特色，我每个 pixel 都独立的啊，那我要一定要独立的 pixel 啊。那因为我做 background modeling， 所以我的 foreground 的值会比较低，所以我只要侦测到这个 foreground， 我比较旁边的 neighbor， 只要有 neighbor 有任何是属于 background 的值，就是比我还高，我就把我自己杀掉。So your result will become here. This is your result using the first method. But you find you cause the overkill. 你杀掉太多，你把 foreground 杀太多了，那怎么办 ？Overkill, you always have overkill. 你杀掉太多了，那我要把 so I need to recover some pixels. So how do they do that? This is the second method. Second method is the same. Suppose it's 5 by 5. So I do the accumulation of the probability for each pixel. It's not actually not accumulation, it's a times 相乘. I multiply each pixel. It's 5 by 5 pixel window. Each pixel, I do multiplication for each one. So I times all together, become one value. So if this value is small, that's meaning this 5 by 5. But actually 3 by 3 is better, 5 by 5 is too big. This 5 by 5 is fine, but this, I always say window size 3 by 3 is better. So suppose 3 by 3, I time this 9 value, and then I find the probability is low. That's meaning we have a foreground pixel inside this 9 pixels. If the value is small, that's meaning this 9 pixel has the foreground pixel, because foreground pixel, their probability is low. And this one is, we remove this one, it's okay. If this 9 by 9 pixel the value is high, that's meaning we have a lot of background pixel, and I'll keep this pixel. So the result will become here. I can recover some pixel back. I say again, this is if this pixel, the foreground pixel, if my neighbor has a background pixel, that's meaning I want to remove this one. So, but it will cause overkill. So how can I recover this overkill problem? What I do is for this 9 by 9 pixels, I multiply together, 乘在一起. If suppose it's only 1 pixel is the foreground, there's 8 pixel background. They time together, the value is high because background pixel, the probability is high. So if this situation, the probability is high, so I will keep this pixel. I cannot delete it. If I time together, the value is low. That's meaning my neighbor has a lot of foreground. So foreground is this one. I need a foreground. So this pixel it cannot delete it. So they will reduce the overkill problems. 那这两个概念常用到哦。When you do the deep learning, the post process is important. So 2 methods are powerful. One is actually this one is first one. First one, we want the threshold is low. When you do the deep learning, you get a result. The result is confidence value, right? The confidence value actually we will do the lower. So if you do the higher, you'll overkill a lot of things. So we do the lower, it will cause some noise, and then we use the post processing to delete the noise. So you want to delete noise. Sometimes you think about the local maxima problems or non-maxima suppression problems. The second, you should consider the neighbor information. Okay, so both methods are important. Both methods. One is try to find the non-maxima suppression. The second is based on the neighbor information. We time together and use the probability to think about we will keep it or delete it. 这两个概念会常用到。So that's it for the background subtraction. Background subtraction 到这里，后面不用看了，就到这里结束。好，那我们这是 background subtraction 的东西。那我们再回来看一下 finish this one. We check the video again. So this is the result. See, this is actually this is a story here. 这是马里兰大学 University of Maryland in 那个巴尔的摩那边，他们的 computer vision 很强。那这是1993年到98年，就我在 CMU 的时候，我们 CMU 有个 team， 马里兰一个 team，MIT 一个 team。We have 3 teams. One is in California, I was there, and then Maryland, and then MIT AI team. 这3个 team 是那时候非常强 ，Vision Computer AI 跟 Computer Vision。那我们刚刚看到这个你看 ，the tree moving, and there's some people come in. And what is this project for? 我们那时候做这个做什么？你知道吗？我们那时候有几个学校 ，we got a grant from the DARPA. Why we do this one? Because we want to kill this person. 因为 DARPA 是美国军方嘛。Right now you have a 那个撞那个无人飞机嘛，我们那时候就在做这些事情。 所以美国我们做的东西现在才发生，你们才看到，我们在那时候就做了。所以美国很多高科技，那我们那时候做是这样子，就 suppose you have some image some camera， 那时候是那个无人驾驶飞机还不普遍，因为是还有，它不是无人，它是有美国就有了，那他们是那个我忘记你们看，让你看一看，它是先因为我们是从地上先做，那你有看到有人在动就杀了，你懂吗？因为那是敌方，你不要在那边，因为他误杀你，这样子。好，那我们发现那时候发现为什么美国人那时候就说 ，in United States the mission is this one, we want to do the war, do the fighting at night， 晚上才打仗，怎么白天打仗？晚上你看不到我，看得到你才会赢啊。所以我们那时候接受到的mission 就是晚上打仗，因为晚上有红外线，美国有你们没有，就这样子啊。所以，来我们继续啊。这是这个，这个很有用。你看，这是不，这是呀，这有人。那时候没有做，那时候是做这个，那现在当然更好。看，这 background subtraction， 那是轿车，这是 the campus of University of Maryland， 他们的 computer vision 很强。好，那我让你看这个，你们做语言嘛？那时候就做了。为什么要语言 ？Fish eye， 你看这个语言，这语言是什么呀？就是反正在这一片地方就放个语言这样无限出来，然后这语言，因为语言可以看到360度嘛，然后这有人在动，所以这很可怕，是只要你动就被锁定了这样子。然后如果多一点的人，就是一颗弹就过来了，就打到了。那我负责做什么？我负责做 stereo。我那时候毕业后也是跟 DARPA 继续合作，所以在学校我们有跟 DARPA， 然后出去公司才看到，那个 James 在学校有跟 DARPA 合作，DARPA 很有钱，所以我做人脸辨识了。然后后面我接一个500万美元，1年500万美元的计划。我说我那时候薪水刚开始是10万美元嘛，那时候了，现在是3倍嘛。因为那时候 CMU 出去行情就10万美元年薪，我们老师毕业，只要老师签 NK 毕业了，那你找到工作就10万美元起跳，别的可能就6万、8万、10万。那我另外一个原因是因为我跟 DARPA 合作，那我去公司有拿一个500万的计划，那个计划做什么？就 stereo。你看，我们做 stereo 做到什么程度是？我那时候就有半年时间，每个礼拜都坐飞机，我是坐飞机上下班的。那我位置越来越高，所以我到4年后，我薪水已经到24万美元年薪，然后坐飞机上下带一个 team， 因为要打那个敌人在雪地上下雪，然后打那个敌人。我在纽泽西纽约那边没有下雪，都到米拉波利斯那边有下雪，放在那边打 stereo， 然后就军方支援我们，就看那个屁股在动，白色哦，全部是白色，他也穿白色，那你总在白色的地方看到有一个屁股有一个头在动，全部白色，我把这技术克服掉，就被锁定，所以在做它这个是 fish eye background saturation， 我用 stereo 加 background saturation， 这有东西，我把这个讲完一下。See these people here. The important thing is that you should not be affected by the wind, by the moving of the leaf. 你不能被树叶影响出现。这是下雨天， 所以我们在做计划，美国做计划没有那么容易，一定要成功才行。不成功就是每年都审嘛，不成功就淘汰掉，钱就没了，那名声也没了。下雨天你要去顶贴这个东西，这有些是他们考验下很大雨，这有时候是DARPA录给我们考试跟你考试的，不行就淘汰。我还蛮喜欢这种务实的东西。好，这是这个，然后这 background subtraction。那 background subtraction 后面就衍生什么？衍生这 graph cut， 这个那是 surveillance and this is graph cut. So similar. So how can you extract the object? So why I want to teach you background subtraction because they are related to this one. So you can change the background. 这个有头发，把它萃取出来。这种实验室有做头发，所以你不能把头发弄掉，头发那个毛你要保留住，那才厉害。然后是蜘蛛网，有蜘蛛网你怎么把？是刚刚讲的，你这个蜘蛛网，我大概是讲一下，这是 这里有，这是 foreground， 这是 background， 这是 uncertainty 的区域，你要多一个 uncertainty 区域，你就是要处理 uncertainty 的东西，不确定的才要处理。你说切下来是这样子，像我们那个 Takeo 常这样讲 ，James 对你很失望，做不好就我对你失望，他就走了，浪费我时间。那时候他是一个教授，年薪20几万美元的教授，是浪费他的时间。他笑笑跟你讲，我是凶跟学生讲，我没有遇到他是你要学会啊，那功力要学会说骂人要笑的骂人，哇，这个功力很厉害。我还没有，那时候我骂学生都凶的在骂，那我们老板以后老板都笑的，骂你笑，我对你很失望，走了，不会常讲。好，那个刚刚是把，我自己看啊 ，this is important。所以 we extract 这蜘蛛网，不知道英文怎么讲，就把蜘蛛网萃取出来，然后 we change the background， 把它放到这里，这假的，这假的。好，那我们再继续看，那后面又继续发展。这影片我们有做，我们创造一个新的，这是学长做的，这影片10几年前做，就把这个移掉，把它补起来。我们出一篇非常好的 paper， 然后那时候我们做最好，全世界那时候做最好。这是过程，就是说你不是你挖完是一个洞啊，不行啊。这之前这之后把它补起来，然后让你看不出之前有一个东西在那里面。那后面好像有人就把这个做到手机里面去了，所以我们做出来很高兴，然后学生毕业了就没有再做了。但是后面公司又把它做到手机里面去。好，最后给你看一个，看一下，这个，这不是我做的，刚刚那有些是我做的，这不是我做的。这是跟 computer vision 有关，不是没有关的，这是 computer vision 的跟有关的东西，跟 graph 结合。它是就是你做任何事情不一定要全自动，它是我不知道现在有没有全自动，因为这已经有点旧了。就你用它就半自动，就用半人工方式嘛。然后这个做一个很好的 tool， 弄起来这个就 extract 出来了，3D 也不是2D。我再讲一遍哈，这是一个方法，这已经旧了10几年前的东西。 那因为没有办法全自动，那半自动没关系。那半自动就是他手用 mouse 这样稍微画一下，那它有 modeling 东西。好，那时间关系，我赶快让你看这 modeling。好，那我们看后面。那既然有这个的话，就可以这样做。model 完了，对不对？把这个 model 完。视觉上那你看，所以欺骗你的视觉。所以一样的技术，你可以 copy。要快一点。好，你把它 extract 出来，然后 extract 同时就不做 3D modeling。哎，这不是 deep learning 东西，是传统的方式。我不知道现在 deep learning 有没有办法做这个，不清楚。对，就可以 copy。好，大概是这个东西，所以几乎什么都可以，像这个一样。看这个不顺眼嘛，它移走东西，所以那可以改变它的东西。3D 可以旋转。对，这很多是 fake 的，假的，可是让你看不出它是假的。大概是这样。Okay, so that's it. So we take a 10 minutes break. It's 20. We will up until 10:30, and we'll continue our lecture. And you go to the FTP site to download. We'll talk about the AI. I'll teach you the AI. So you please go to the FTP site to download the lecture. 05, number 05 lecture with AI.